My name is Ibnu Fayachika Adiwangsa, and today I will explain about Lorentz force definition. What is Lorentz force? Lorentz force is a combination of magnetic and electric force that acts on a point charge due to the presence of electromagnetic fields. Lorentz force explains the equation of mathematical nature along with the physical importance of forces which act on the charged particles. Moreover, these particles travel through space which contains electric and magnetic fields. Lorentz force happens when the movement of a charged particle takes place through magnetic fields and cuts through field lines in the process. This force acts at right angle to both the particle velocity and the magnetic field. This force direction in various situations is dependent on the direction of the velocity of the particle and the magnetic field, as well as the sign of the particle's charge. There are two ways of remembering the direction of this force, and both these ways are the variants of the left-hand rule: thumb, first finger, and the second finger. These are held at right angles to each other, and a rotation takes place so that the pointing of the first finger is in the direction of the magnetic field. Furthermore, the pointing of the second finger is in the direction of the current, and the pointing of the thumb's direction is in the direction that the motion will tend to if the magnetic force is the only force present.
My name is Muhammad bin Kamaruzaman, and now I am going to present about the Lorentz force formula. So basically, Lorentz force formula is the sum of electric force with magnetic force. As we can see here, the Q is for the electric charge, and E for the external electric field, V for the velocity, and B for the magnetic field. So let's say a charge Q resides at point R and is moving at the velocity V. Somewhere, other charge and currents have generated an electric field and magnetic flux density. So a force on charge Q can result to this equation. Hence, the force due to the external electric field could be parallel to velocity vector V. That's all from me.
Hi, I'm Nur Aina Nabila binti Ismail. I will give some examples of Lorentz force law. Lorentz force plays a crucial role in various applications ranging from electronic devices and motors, sensors, imaging to biomedical applications. Here are some examples of Lorentz force law. Cyclotrons. Cyclotron is a type of compact particle accelerator which produces radioactive isotopes that can be used for imaging procedures. Second, mass spectrometry is an analytic tool useful for measuring the mass to charge ratio of one or more molecules present in a sample. Third, velocity filter removes interfering signals by exploiting the difference between the traveling velocities of desired seismic waveform and undesired interfering signals. Magnetron is a high-powered vacuum tube that works as a self-excited microwave oscillator. Last but not least, Lorentz force velocimetry is a universal flow measurement method for electrically conducting fluids.
We need a battery, a circular magnet, and a copper wire. The first step is we will connect the magnet at the bottom of the battery. Okay, and then we will cut the copper wire and we fold it into any type of design you want. And then we will put it at the positive of the battery. As we can see, the copper will spin around the battery, and this is, we can see it such as a motor.